Hello learners, I welcome you all to this video program on distribution of salinity in the oceans. In the previous video program, we studied about the distribution of temperature in the oceans. Both temperature and salinity are important physical properties of ocean water. So in this video program, you will study about the most inherent and unique physical property of ocean water, that is salinity. You will learn the definition of salinity, the composition of seawater, factors affecting salinity in the oceans, and horizontal and vertical distribution of salinity in the oceans, like the way we studied the horizontal and vertical distribution of temperature in the oceans in the previous video program. So we are all familiar with the salty nature of oceans. Do you know what is the source of this salt? Yes. The salt actually comes from the land areas. The rain water dissolves enormous amount of salts and flows as surface runoff. The river water streams all wash up the land surface and contain dissolved salts. And since we have studied while studying the hydrological cycle that the slope of the land is towards the ocean, so everything gets deposited into the oceans. So every year rivers deposit millions and tons of dissolved solids into the oceans. So oceans contain unacceptable amount of dissolved salts and chemicals which bring their inherent salty feature and is different from the fresh waters like rainwater, river water and stream water. So we can imagine that primeval seas must have been slightly salty since rivers are depositing salts every year. So every year salinity is increasing. But you should also remember that rivers, apart from depositing salts, are also depositing enormous volumes of fresh water into the oceans. So a kind of balance is maintained, although salinity is increasing to some extent but not to that extent. A kind of balance is also maintained by the amount of fresh water which falls in the form of precipitation and the river water which drains into the oceans. The famous oceanographer Joly states that if all salts of the oceans were dried up and spread over the globe, it would form a layer of about 45.72 meters. So you can imagine how much salt is dissolved in the oceans. So we can define salinity as the ratio between the weight of the dissolved material and the weight of a sample of seawater. So the total amount of solid materials which is calculated in grams contained in 1 kilogram of seawater and is expressed as parts per thousand. So let me explain. If we say salinity is 20 per thousand, it means 20 gram of salt is present in 1000 grams of seawater, because 1 kilogram is equals to 1000 gram. So per cent is per 100 and per thousand is per kg. We can say it is per kg. So it is salinity is expressed in terms of number of amount of grams of salt contained in 1 kg or 1000 grams of seawater. I have already explained that the balance of salinity is maintained, how the balance of salinity is maintained. Now, what is the significance of salinity of seawater? Salinity is one of the most important physical properties that affects other properties of seawater like density, temperature, pressure, waves and currents. We are going to study the oceanic circulation in the form of waves, currents, tides in the next or subsequent video programs. But here we are covering only salinity. But let me explain how salinity affects the temperature and density. Like when salts are dissolved in water, definitely it will become denser compared to the fresh water. So its density increases. And the temperature also increases because salinity, as salinity increases or with the help of dissolved salts, the solar radiation is scattered, and due to which the temperature of the seawater increases if salinity increases. and density I have already explained. Now salinity lowers the freezing point and increases the boiling point or lowers the evaporation rate of seawater. Let me explain this. Like seawater contains dissolved salts, and suppose the most common salt present in seawater is sodium chloride. So when sodium chloride dissolves in water, it forms a stronger bond with water, and to break that bond, compared to the sodium chloride, a stronger bond is formed, and so to break that bond more energy is required. So the boiling point increases when salts are dissolved in water, and since boiling point increases, so rate of evaporation is lowered. You understand this thing? And since the stronger bond is present after the salts dissolved in water, so it lowers the freezing point because it is opposite to the boiling point. So freezing point is lowered in case of high salinity. So it is very significant while studying different processes in the oceans. This property should be studied in detail. Now, through various expeditions by different famous oceanographers, they have found that 47 different salts are present in the sea water, and the most common method of extraction of salt are the titration method and the hydrometer method. Average salinity of different oceans and seas varies between 33 per thousand to 37 per thousand. And as I have already told you that sodium chloride is the most important constituent of seawater. Other elements are silicon, nitrogen, phosphorus, etc., forming respective salts like silicates, nitrates, phosphates, etc. Let us see in this table. You can see the salts are mentioned in the left part of the column, like sodium chloride, which is the most prominent salt present in seawater. You can see if we consider the average salinity as 35 per thousand, then the amount of sodium chloride is about 27 per thousand. And then we have other salts like magnesium chlorides, magnesium sulfate, calcium carbonate, etc. And you can see the rightmost column is shown as percentage, in terms of percentage. So both in terms of per thousand and in terms of percentage, the amount of different salts in the sea is shown in this table, and you can compare them. Now, what are the factors that affect the salinity of the oceans? Like we studied the factors that affect the distribution of temperature in the oceans. So let us study the factors that affect the salinity in the oceans. So most important factors are evaporation, precipitation, influx of fresh water from rivers, and atmospheric pressure and wind direction, oceanic circulation in the form of currents and tides. Let me explain these in detail. Like evaporation has a positive correlation on the salinity, because while during the process of evaporation, the water content of the sea water evaporates, and what is left behind is are the salts. So definitely salinity will increase. According to WUS, the average evaporation from all oceans is about 93 centimeters per year. Now, coming to precipitation, you see that you can just correlate. Precipitation has a negative correlation on the amount of salinity. Since fresh water precipitates in the form of rainfall or snowfall, whether it is in equatorial regions in the form of rainfall, or it is in the polar or subpolar regions in the form of snowfall, they will increase the water content in the ocean water, so the proportion of salts will automatically decrease. So this is a negative correlation. So precipitation has a negative correlation. So that means that higher the precipitation, the lower the salinity of the oceans. Now Similarly, influx of fresh water from rivers will also reduce the salinity at places like river mouths of some of the major rivers of the world like Nile, Amazon, river Ganges, then Irrawaddy and other rivers, you can say Congo, Niger, etc. There are so many rivers which drain enormous amount of fresh water into the oceans, and the river mouths have recorded very low salinity compared to the places in the same latitudes. Now, atmospheric pressure and wind direction also affects the salinity of the oceans. Like let me explain atmospheric pressure first. Like in subtropical high pressure regions where there are calm conditions, anticyclonic conditions prevailing, salinity will increase. And wind direction also has effect on salinity, like take for example trade winds. Like northeast trade winds, southeast trade winds, they blow from the eastern part of the oceans, they deposit water towards the western side of the ocean. So, they are responsible for piling up of water in the western side of the oceans, and so there is a decrease of salinity in the eastern side or the western coast of the continental areas, and the western margins of the oceans show an increase in salinity because the wind direction is towards them. Now, coming on to oceanic circulation in the form of currents and tides, just like the effect of winds, ocean currents and tides also affect the salinity of the oceans. Like warm ocean currents, take for example north equatorial warm current will increase the salinity in the western margins of the oceans and decrease the salinity in the eastern margin, because they are moving, the current is moving from the eastern part to the western part of the ocean. So, salinity is also affected that way. And similarly, tides are vertical movement of vertical rise and fall of the sea water. We will study in detail about currents and tides in the next video program. So, tides are the vertical movement of ocean water under the influence of gravitational force of moon, sun or other heavenly bodies. So, you can see that when the vertical movement is of ocean water is brought about, the entire water circulation is from the bottom of the oceans to the top of the ocean. So, there is a kind of redistribution of salinity in the oceans in this way. So, these were the factors which affect the salinity of the oceans. Now, let us study the distribution of salinity of the oceans, both in terms of the horizontal distribution and vertical distribution. Like we studied in the previous video program, the horizontal and vertical distribution of temperature in the oceans. Horizontal distribution is studied in two ways, like latitudinal distribution. We see the trends of salinity from equator towards the poles, and regional distribution. In terms of regional distribution, we take major oceans as separate regions and discuss the salinity trends. So, while discussing or studying the horizontal distribution of salinity, we study with the help of isohalines, which are imaginary lines drawn on the maps joining places of equal salinity. Now, coming on to latitudinal distribution of salinity, it has a general trend of decreasing salinity from the equator towards the poles. But let us reason out, will the equatorial region be regions of highest salinity? No, because equatorial regions are having high amount of precipitation also. So, in equatorial areas, precipitation exceeds the evaporation rate. So, salinity is lower in equatorial areas compared to the tropical areas. So, tropical areas are having the highest salinity, and because of high temperatures and high evaporation prevailing in those regions, which exceeds the amount of precipitation there. So tropical regions are having higher salinity. So when we see the latitudinal distribution between 20 to 40 degree latitudes in the northern hemisphere, salinity reaches about 36 per thousand. In polar regions, there is further decrease in salinity just because of the precipitation in the form of snowfall, which increases the amount of fresh water content in the ocean. So, salinity is decreased. Average salinity of the oceans of the northern hemisphere is 34 per thousand and of southern hemisphere is 35 per thousand. Can you reason out why southern hemisphere is having slightly higher salinity? Yes, you can guess that southern hemisphere is has a higher proportion of oceans compared to the northern hemisphere. So, greater amount of rivers drain water into the oceans in the northern hemisphere, thus decreasing the salinity, and the salinity trends are more regular in the southern hemisphere and slightly higher compared to the northern hemisphere. Now, in the following table you can see latitudinal zones, different latitudinal zones are shown. You can see in the center the equatorial zone exists like 10 degree, 15 degree north to 10 degree south is having 34.5 to 35 per thousand salinity. But you can see in the tropical regions like 15 degree north onwards, salinity is increasing. So, highest salinity you can see, compare both the hemispheres. The southern hemisphere also 10 degree to 30 degree south is showing 35 to 36 per thousand salinity, and 15 degree to 40 degree north is showing 35 to 36 per thousand salinity, and salinity trends are again decreasing towards the poles. You can see that the 50 to 70 degree north latitude is showing 30 to 31 per thousand salinity, and 50 to 70 degree south latitude is showing 33 to 34 per thousand salinity. So, you can see that the salinity in the southern hemisphere is slightly higher compared to the salinity in the northern hemisphere, and you can also compare the trends, how they decrease towards the poles and how tropical areas have higher salinity compared to the equatorial areas. Now, let us study the regional distribution of salinity. First start with the Atlantic Ocean. So, Atlantic Ocean has average salinity of about 36.67 per thousand. And when we see the world map with the isohalines showing the salinity in different parts of the oceans, after one or two slides I will show you. You will see that the Atlantic Ocean is affected by the presence of warm ocean current like Gulf Stream, North Atlantic Drift. So, isohalines are slightly curved towards the north, and so you see that 35 per thousand salinity is even found up to 70 degree north latitudes along the Atlantic Ocean, along the northwestern Europe. And we can see that trade winds also lower salinity along the western coast or the Guinea coast of Africa. In the southern hemisphere, you can see in the Atlantic Ocean that isohalines are more or less parallel in all the oceans you will see, and the mouths of the rivers have low salinity. So, these are the important points you should remember while studying the salinity of the Atlantic Ocean. Let me come to the figure over here. In this, the horizontal distribution of salinity, like I explained, you see that along the northwestern Europe, you see the salinity isohalines have a tendency towards is affected by the warm ocean currents like North Atlantic Drift, and so they are turning slightly upwards towards the north, and you can see that in most of the oceans the salinity in the southern hemisphere is almost parallel. Now, coming to the salinity in the Indian Ocean. Indian Ocean shows more complex salinity conditions due to the presence of the Indian subcontinent and the monsoons, and you can see in the map that the 35 per thousand isohalines divide the ocean into western and eastern parts. So, this is one unique feature you can see very clearly in this map, that below the Indian peninsula, you can see that the 35 per thousand isohaline, it is just straight connecting there, and it is dividing the Indian Ocean into two parts, the western and eastern part. You can also compare, as oceanographers have reported very low salinity where rivers are draining, or at the mouths of rivers where they pour water into the sea. So, along the mouths of giant rivers like Ganges, Mahajan, Nadi, Godavari, Krishna also salinity is reduced. Arabian Sea records slightly higher salinity due to less influx of fresh water compared to the Bay of Bengal. And along the western coast of Australia, maximum salinity is found due to arid conditions prevailing there. You should also note that some of the enclosed or partially enclosed seas like Red Sea, Persian Gulf records exceptionally high salinity in the Indian Ocean. Now coming on to Pacific Ocean, salinity conditions in the Pacific Ocean is quite varied due to its vastness and its unique shape. Between 15 to 20 degree latitude, salinity is recorded at about 35 per thousand. Also, it has effect of ocean currents like cold Oyashio current, which decreases the salinity along the Okotok Sea. Along the California coast also, due to upwelling of cold water from below the ocean surface, salinity is decreased, and the transfer of warm water by ocean currents and prevailing winds also affect salinity in this Pacific Ocean. Similarly, at the mouths of the giant rivers like Huang Ho, Yangtze Kiang, salinity is reported quite low compared to the adjoining latitudinal zones. Now you can compare, in this map you can see different oceans and compare it once again to have a detailed understanding of horizontal distribution of salinity. Now let us also study the vertical distribution of salinity. Since oceans are three dimensional, so we need to study the vertical distribution of salinity also compared along with the horizontal distribution of salinity. There is no regular trend of increase or decrease of oceanic salinity with depth that has been reported by famous oceanographers. Salinity increases with depth in high latitudes. In the middle latitudes, salinity increases with increasing depths up to 200 fathoms, and thereafter it starts declining. And in the equatorial regions, it has been reported that the surface area is having low salinity, and just below the surface salinity increases and again starts decreasing towards the bottom of the ocean. So, these are the trends which have been reported by some of the famous oceanographers in their various expeditions. So, in this video program, you studied about the salinity of the oceans and the factors affecting it. You studied about the horizontal and vertical distribution of salinity in the oceans. In the next video program, we will study about oceanic circulation in the form of tides. And then in the subsequent video program, we will study about ocean currents. Thank you.